Good afternoon. My name is Claire and I'm the Business Coordinator here in Elquig, and I would like to welcome you to the TTF webinar. I'm here for the introduction part of the webinar. You will see the chat function at the top of your screen. If you have any questions during the webinar, please put them in here and we will have a Q&A session after the presentations. Thank you, and I will now hand you over to your first presenter, Henrik.
Hello all. I will start sharing my slides right away and get into the presentation. So please let me know if you cannot see my screen. Otherwise, I think we should be good to go. So I'm here representing Naira Dynamics. So we are a virtual sensor company. We've been working within the automotive industry for the last 20 years, creating different software solutions. And we are now owned by the VW group. So we have software within their vehicles that we're then able to create hyperlocal measurements on the road state and different data pertaining roads. So if we zoom in a bit and look at the UK, in the UK we have about 100,000 vehicles active, or I would say at least 100,000 vehicles active, probably a bit more now, and they create and collect data such as available road friction, so it's a friction estimation, ambient temperature, the wetness state of the road surface, and road surface temperature, as well as measurements on roughness and potholes and road damages. So how do we create this data? So as I mentioned in the beginning here, we're owned by the VW group. So we have data or software within their cars that create data. So the software, we call it Tire Grip Indicator, which collects data from about 25 different sensors within the car, but we only install software in the car. So it's put in on the assembly line with no additional hardware. And that then collects the data, sends it up to the Volkswagen backend. And then they anonymize it, aggregate it, and send it over to our backend, where we combine it with additional data types, mainly then weather data. And that allows us to create a different set of map layers or KPIs pertaining to the road state. So I will be showing our two main product portfolios, which is road health, which is for summer maintenance, and the winter road insights, which we use for the winter maintenance. So the products that is created, I think I mentioned a couple of these during the previous slides, but it's slippery road, so that's in the winter. We have slippery when wet, so basically detecting areas that are prone to hydroplaning, and then road state, which is based on the IRI index, so it's a comfort index. Potholes, which is pretty self-explanatory. You can point out a potential pothole with a GPS coordinate. Wetness of the road surface, so that could be used to detect places where the drainage is not working properly, as well as the surface temperature of the road surface. So then we have the road health and winter road insights. So road health is what we see to be used in the winter or summer maintenance, which allows you to know a always up-to-date current state of your road network. We monitor about 99% of class 1 roads, so the highways, every day, and about 95% of class 2 and 3 roads, so that would be connecting roads or arterial roads and stuff like that. But this daily data also allows us to create trends, which is not possible with traditional road surface measurements. So we can see how the trend is developing. If we identify areas where the trend is starting to deviate, you can go out and correct that before it gets too bad. We also create alerts when there's a very quick shift in the trend. So that could be cracks starting to form, or bridge joints, for example, shifting. And also we create alerts for any new potholes that have been created. On the winter side of things, we measure the friction, which then allows you to have a direct follow-up on your daily maintenance work, the salting mainly. See if you put down enough salt, too little, or potentially too much. We also can create KPIs and historical evaluation to help you optimize and lower the amount of salt, both to save on cost and also, of course, the environmental impact. You have an always live status on how the road is, where roads are slippery, where the grip is good. And we send out alerts if there's a slippery area identified. Not mentioned here is also creating thermal mappings of any area, so you can know which areas in your road network you should look out for when it's around the freezing point, to see maybe where you should go salt first. If we look into the data a bit more in, I guess, the empirical evidence, we've done a study with a white paper with Purdue University, where we measured our crowdsourced data compared to a IRI standard laser profiler. And as you can see, the red dots is the crowdsource roughness, and the black triangles are the profiler. And there's a pretty strong correlation. We tend to measure a bit above the profiler, but our claim is not that we're millimeter perfect. It's more like a repeatable continuous data flow. So the millimeter accuracy is not at the same importance as when you do a yearly or every 3-year measurement of the road network. And then going in to pricing for cities, we have a price then of the option 1 package, which we call this, which is the standalone NIRA service, which you get our data and graphical user interface, and also a long-term planning on how to create a maintenance plan. And that is so 0.09 euros per inhabitant for a city and year, and with a minimum limit of 5,000 euros. And then we also have a full PMS solution where you get a full PMS system. You also get a guaranteed coverage of 100% of the road network. So if there's any missing spots that our fleet is not picking up, we will go there and measure it with a Volkswagen vehicle as well. And that is then 25 euro cents per inhabitant a year, and a minimum of 20,000 euros. So that was all for me. Thank you very much for your attention. I don't know if we take questions now or if we save that until later. I guess later. Okay, I have some questions in the chat. Yes, the white paper If that is what Chris Kettle is asking about, it should be linked in the presentation, in the slide. So yeah. And in the UK, it's approximately 100,000 to 120,000 we collect data from. We do use acceleration data or torque data to. I don't know. Sorry, Ali, what you mean with black spots. I'm not familiar with the term.
Areas where there's more than a cluster of collisions. It's a bit of an old term now.
Okay. Accident prone. That is actually a product we're on the way on launching, which is we call a new product portfolio called road safety, which is more in the harsh braking, strong accelerations, road signs, and stuff like that. So it's not available at the moment, but will be Q2 probably, so before summer.
Great. Don't think there's any more questions. Thank you very much, Henrik. Hopefully you can hear me now. So a couple of people have emailed me to say they have had a similar problem, but we've got 34 people in, so Teams hasn't let too many people down. I won't do my introductions slides. All I'll just say is that we're focusing today on new communications and new data. And at the end, I'll give you an update on some funding from the DFT and some new data. So without further ado, I'll ask Wesley from ASIN to give us his presentation. Thank you.
Hi everyone, hi Andy. So I know we've got a few bugs this afternoon. Just want to check that, can everybody see my screen all right?
Yep.
Perfect. Okay, well first, thank you everybody for the opportunity to discuss. And my name's Wes, and I'm the UK lead here for Road Trace here in the UK. And it's a product released called Connected Insights by ASIN, Aishin, as it's called in Japan. And we're here to discuss and talk about our mission. And our mission is to harness insights from connected vehicle data to enhance road safety and ultimately save lives, and how we link that to the ITMF. So for those of you that do not know ASIN, we come from a rich history in the automotive sector of manufacturing safety equipment for the automotive OEMs. So we're the 5th largest supplier in the world, with 30 billion worth of turnover, operating in 21 different countries. And traditionally, people know us for the chassis where you see in the blue, the vehicle and safety systems, which whether you drive an Audi, Toyota, Citroen, Mercedes, we supply the safety equipment that goes inside the vehicles. Now, from a Road Trace perspective, which is the team I sit in down at the bottom right-hand side, in the connected sharing solutions division of the organization. So here we're proud to be part of this section. People know us historically in the market for first launching satellite navigation systems 30 odd years ago, and being leaders in the connected car and data for the industry. So I want to talk a little bit about our main global customers from an Aishin perspective. This isn't our exhaustive list. These are the manufacturers that we supply safety vehicle equipment safety for. These are obviously, as you can see, not the exhaustive list, but some of the largest automotive companies in the world. But most importantly, when we're coming and talking about data, it gives us access to the widest possible range of data being generated by connected vehicles across the world, but more effectively for the UK. So we get asked a lot, where is our data from and where do we generate insights from? So we carefully choose our data sources. So going back, we talked about the automotive OEM sector, where we obviously have the relationships with, but we also work with fleet managers, telematics providers for a very good reason. And the reason is that we need to, and we believe that to generate statistically representative data and insights, we need to be data agnostic. So that is a really key strategy that we've taken at a global level. and we listen to local authorities and everybody within the industry that says to be statistically representative, you need more than one data source. So an example of that, it's public knowledge. TfL publicly states that they use Mercedes-Benz data, but that is only statistically representative of Mercedes-Benz vehicles and only their vehicle set. The second point around us is what differentiates us from, say, Google or other floating car data providers, and it is the information comes directly from the vehicle sensors inside the car and the onboard computing. We do not need any additional hardware. Everything is already being collected by the automotive OEMs, the telematics providers and the fleet managers. So it's important to mention that, as others know, that everything is anonymized at source to comply with GDPR compliance at a European and a global level. And when we're talking about data, we are not tracking individuals. We are talking about looking at collective driving behavior. So I wanted to put this slide up here because as an automotive safety OEM, which is our background and our DNA, we've spent 2 years working very closely with LCRIG, with local authorities across the UK and the members of which we are a member of, and listened to how and what do they see from, what do they want to see, sorry, from connecting vehicles and what is going to add value to highways teams. And this involves accessing, as I mentioned earlier, vehicle sensor information to generate real world driving behaviours. And the most important thing that came up over the last 2 years has been road safety, and road safety emerged as that highest priority. And so for that, we introduced harsh braking data insights tailored for local authorities and road operators. And through this initiative, we analyse driver behaviour and we pinpoint and can show where accidents are most likely going to occur on a road network. Now, these insights empower clients to prioritise and actively investigate these causes. And these can be, as we all know, poor road layouts, maybe traffic systems, potholes, signage. But the key is that it shows the driver behaviour before accidents transpire. And that was key to ensuring a safer road for all. So I wanted to highlight here, I know we've only got 10 minutes today, but the slides are available afterwards. There is a recent success in Blackpool. This is a government geospatial report, which now shows and serves as a concrete example of where road trace can be a preventative and safety tool to work with us on. But how we link that to then the ITMF and combining that to insights. So expanding on those, from the connected vehicles, we have the harsh braking. And we listen to other local authorities as well. And what's key to the ITMF is around the R&D functionality and the application process. So we've taken the harsh braking and we are now incorporating relative traffic flow and also average speed. So the combination of insights into traffic patterns, accidents and incidents can empower local authorities and road operators to make informed decisions. So what we're suggesting is that any traffic management initiatives should start by performing an analysis in a data-led approach to understand the current driving behaviours within the road networks as part of that process. And what we do, we're not looking to bury local authorities within data. We provide the insights. We have our data science team, which will help through that process. So these analyses can help inform managed traffic management schemes in the future. And most importantly, one of the key things is to link back and look at, well, how has the driving behaviour changed over the course of time? So finally, on the how do we link it to the ITMF? So with our R&D focus, by combining the harsh braking, relative traffic flow and average speeds, it's an all-in-one encompassing piece that we will work on with you. Our insights are using connected vehicle data and AI techniques to show that risk-based analysis on the road networks. And finally, I wanted to leave you with the what their statement says. So although authorities are expecting to propose solutions that benefit traffic management in their areas, the ultimate aim of the ITMF is to show real world showcases of new technologies. So we hope that by partnering and continuing to work with Road Trace, we'll push that to the limits through the ITMF process. So I wanted to just finally show you a video. It's the last part of my presentation, and here it is. Cool. So I'm not sure. I saw some comments on there that said some could see it and some couldn't see the video. So apologies if some of you have and some of you haven't. My details are here. That's the end of my presentation. And thank you. And I'll hand back to Andy. Andy, you're on mute.
Thanks very much. I'm here now, and I think you can hear me. Good. Yeah, sorry about the IT issues. I think everyone who's wanted to get in has got in now. There'll be questions about 2G and 3G. I'm sure Peter will talk about that later on in some of his slides. So first two presentations are data direct from vehicles, something that people have been asking for a long time, directly from OEMs. The next presentation is from Richard and Owen of Agilicis, and when I spoke to him some time ago, I was very interested because his data collection was from a very new source, which I won't steal his thunder on. So over to you, Rich.
Thank you. Okay, let me just get this presentation going, shall we? And hopefully everything's working there and you can all see the screen.
Yeah.
Let's move that out of the way, shall we? Great. So yeah, I mean, we work in Agilicis on lots of connected vehicle data from various different suppliers in the UK, overseas, including lots of low and middle income countries. It's amazing how many different suppliers there are of vehicle data around speed and volume at the moment. But what do you do where you don't have access to that data? How can you work in some of the lowest income countries to try and get critical information that we all take for granted, such as where vehicles are and how fast they're traveling? So yeah, let me just take you through a presentation here about a project that we did alongside IRAP, who many of you will have heard of, on behalf of the Global Road Safety Facility. So, we've got a long history of carrying out geospatial data and analytics. We've carried out various different projects on data modeling, etc. You can see lots of the standard feature detection that we've done using vehicle sign data, detecting objects from in the vehicle or from above the ground, or using connected vehicle data to generate AADF maps that you can see in the top right hand corner there. But we've been really interested in other sources of data in those other countries. So yeah, this was an R&D project, very much trying to figure out how it might be possible to achieve access to similar data in other countries. And we chose Kenya and Ethiopia as the two countries that we wanted to look at, because we know that there is a lack of data within Africa. The two of the questions that we were trying to answer here are related to UN road safety targets. So there's one, target number 4, which is that by 2030, more than 75% of travel on existing roads meets high technical standards. That's normally a star rating, so a 3-star rating if you're familiar with the IRAP program. And then the second one is around the level of speeding that exists. So halve the proportion of vehicles traveling over the posted speed limit on roads. So, for that, you need to know where the traffic's moving and the vehicle speeds, of course. So we looked at 3 different data sources here, some of which are free and some of which cost you some money, depending on how much data you want to buy. So on the right hand side there, you can see Mapillary. So Mapillary is kind of like an open source Google Street View. Some of you may be aware that you can't actually just steal Google Street View images and use them in your own research or presentations or anything like that, because Google will come down on you like a ton of bricks, and they've got better lawyers than I can afford. So you can't use their data to take out features and do feature recognition. So Mapillary is basically people with dash cams driving around the world, and you can access that free of charge. You've also got open mapping networks, so OpenStreetMap, which is the one in the middle. So we know about the road networks. And then the one on the left-hand side is a whole selection of EO data, so Earth observation images, so satellite imagery that we had to buy for individual road networks. So we wanted to buy that because we thought we had a clever idea to identify vehicles and see how fast they were traveling on the road networks. So yeah, let's have a look at the EO data there. So yeah, I believe you can see in there, there's a nice image of somewhere in Kenya. And what you can see is the little boxes around the outside of those. So what we did is we bought thousands of these, and then several people in our team spent a dull couple of weeks drawing bounding boxes around these so that we could use these to train our AI model. Everything's AI these days, isn't it? And then you repeat the exercise with the model and then continue to retrain it, and you hold back some of the imagery so that you can test it. But basically, yeah, it's pretty standard AI procedure to then identify vehicles. So now we can show our AI model any satellite image, and it will go through and it will count the number of vehicles on the road. So that's quite good if you want to count vehicles that are on the road and try to avoid the ones that are off the road, of course. But in order to work out traffic flow, you ideally need to know how fast they're moving. And that was the tricky thing. So we had an idea of how this could be done. And we managed to achieve that by taking two individual images. So when you buy EO data for anywhere in the world, you actually get a batch of images. You get the nice color picture that you can look at, but you also get a series of images at different parts of the spectrum, the light spectrum. So this and those images are taken half a second apart. So we know that within half a second we can identify a vehicle and then see how far it's traveled in that half a second. Obviously, the vehicles need to be going at a reasonable speed. If they're crawling along at less than about 12 miles an hour, then we can't detect it, just because you're talking about a 50 centimeter resolution of the images there. It's just not moved far enough to be able to detect that. But yeah, you can see the red and the blue blobs on there, which is showing vehicles and how fast that they've moved. And then, with a reasonably clever data scientist, you can then have a look at this information and then work out how far those vehicles have traveled, and then calculate the speed that they've traveled at. So that's a way of detecting vehicle movement using the EO data. Of course, when you've done that, you need to map that across an entire network. So here are those networks for Kenya and Ethiopia. So this is where we bought all of that satellite imagery for those countries. And what you can hopefully see is that we've got different speed values there. Typically within Addis Ababa and Nairobi, you get much lower speeds, but on the interurban roads, you can often get some higher speeds. And then once you know how many vehicles are on there, because you've counted them using your AI tool, and then you've worked out the difference in the speeds using those two different images, you can then answer that first question that the UN road safety target looked at, which was around percentage of travel. So, this is what 75% of travel looks like in those two different countries. So the dark blue colored ones are the roads that have the most amount of traffic on them. And then the light blue ones are the ones that we analysed that didn't have that 75% of travel. If you're wondering why the 75% of travel matters, it's just so that you can narrow down the part of the network that you want to improve. The idea goes that if you can improve the relative safety by investing in better road builds and enforcement and other measures as well, then yeah, you can have the biggest impact on road safety. So 75% of travel is typically only around 10 to 11% of any road network anywhere in the world. We're looking at this in Southeast Asia at the moment using this and some other data from telematics systems where that's available. So yeah, 75% of travel, about 10 to 11% of the road network. So you can see why you might want to prioritize your investment there. We did a whole bunch of other stuff as well that I'll just show you while I've got my 2.5 minutes left, at least 2 minutes. You can use a lot of this stuff to identify locations of pedestrians, pedal cyclists, motorcyclists, which is really useful if you want to count the presence of those, because you can't detect them from space. 50 centimeters, unless you're really quite large, you're not going to fill an entire pixel on a satellite imagery with a 50 centimeter resolution. So yeah, we could do that kind of thing. We could also detect infrastructure as well. So we've actually got a pretty good AI model for detecting zebra crossings from space, or zebra crossings if you're an American. So yeah, we've got a really good model that allows to detect that. So yeah, that's quite handy for some authorities. But then we also looked at some of that lower level road data, so that mapillary stuff, to identify speed limits, because you'd be surprised about the lack of information about speed limits on road networks. So we use that to identify signs and then try and build up speed limit maps. At the end of it, we managed to achieve AI RAP accreditation. So that comes from IRAP. So we are one of only 2 people in the world that have got that accreditation to look at average speed, 85th percentile speed and traffic flow across anywhere in the world. Obviously, you know, we're focusing more on countries where there isn't that telematics data available. And these are the kind of countries that we worked in at the moment. So, I mean, you can see the UK coloured in there. We did try out using some UK roads first of all, so that we can validate the findings against known traffic flow and speed data. But yeah, we've used it in Colombia, we've used it in various different parts of Africa, Southeast Asia, and are looking to expand it worldwide. So yeah, that's what I wanted to talk about here, just some examples of how you can use some other data sources to try and find out information about the vehicles that are using your road network.
Cracking. Thank you very much, Richard. I'm very pleased that you were able to speak, because we tend to focus a bit too much in connected vehicles on the vehicle itself and not on other data that can be used to triangulate and verify and so on. I know there's going to be lots of questions at the end. Interesting that you can find speed limits. Apparently in the news, there's news about a false 50-mile-an-hour limit that's been put up on the A2. People have sped up and then been given tickets, so maybe there's a use case there. So thanks very much for that. Take questions at the end. If many people that we know would say at this point, well, so what? So you've got all this lovely data from vehicles and from space. What can we do in terms of warning drivers about things ahead? So our next speaker is Gareth from Hasselert, and he's got a solution to that problem. So over to you, Gareth.
Thank you very much, Andy. Let me just share my screen. Perfect. And Andy's teed that up very nicely. So what? So we've got all this great data. How do we help influence safety on the roadways? So just to introduce myself, so I'm Gareth Evans. I'm the Director of Business Development and Strategy for Europe for Hasselert. We're an established company in the United States, and we launched over into the UK and Europe around about 8 months ago now. At the core of what we are and what we do, we're a safety company that's helping build a world where everyone gets home safe. At the center of what we do is our safety cloud. Essentially, what Safety Cloud allows us to do is to provide alerts and information to drivers and people on the road, and we use the term beyond real time. So rather than seeing something either when it's too late or when you need to react quickly, the idea with our Safety Cloud solution is we can provide information to drivers well ahead of time, be that 30 seconds, a minute, or even a minute or longer, depending on the use case. Before I go into the details, I thought it'd be good to take a step back and look from more of a holistic view of why we exist and where we sit in the landscape of the connected world. So what we found and what we've just heard from the great people before me is there's so many crucial but also very advanced connectivity in all these different areas that you can see on the screen. So from emergency services, for V2V or that V2X infrastructure, but oftentimes they sit separately. So how do we start to bring all of that together? And Safety Cloud sits in the middle of that. So the example being in the United States, we work with the Homeland Security, FEMA, and US Fire Department to help drive alerts into vehicles to help from a natural disaster perspective. We're also helping actual car manufacturers communicate with each other, something I'll go onto shortly. But then also in the very rapid world of how we're changing, we're very soon going to have autonomous vehicles, semi-autonomous vehicles, and also vehicles that are 25-year-old on the roadway. How do we bring all of that together to help people stay safe? We also recognize that we can't do that on our own, and we do not want to do that on our own. So in the United States, this is just a small snapshot of the people that we partner with that utilize Safety Cloud. We're bringing that over into Europe, and we already have some pilot programs in the UK, France, Germany, Netherlands, soon to be Spain, and many other European countries, of how we can start to bring these different areas together, be that work zones and infrastructure, be that static or dynamic, with the OEMs or with the towing operators, or let's call it the blue light, amber light, and red light services. So focusing a little bit more on those guys, we know that we've got traditional ways of alerting people on the roads, something that has been tried and tested. However, if we lived in a perfect world, we wouldn't have news headlines and news stories like this globally. This isn't in isolation to the UK. We see this in every single country, whereby, unfortunately, despite all the best efforts, there is accidents involving fire engines, tow truck operators, roadwork operatives, and many more. So our aim is to connect all of these different areas on the roadways and be able to produce that information so drivers are alerted ahead of time, so they can change their driving behavior and driving habits before it's too late. Ultimately, anything that's on the roadway where we can connect and we can drive digital alerts, we are looking to do that. So be that with the blue light services, roadwork operators, or tow truck operators. In the UK, we already partner with the IVR, the Institute of Vehicle Recovery. We have some pilots getting underway with emergency services, and the same with road operatives and also equipment manufacturers as well. So how do we get that to drivers, and what do drivers need to do? Essentially, drivers need to do nothing. A driver never needs to know HazAlert exists. If they use Waze, if they use Apple Maps, and if they have some newer vehicles, which I'll speak to in a moment, this will come as a standard feature. So they don't have to download anything. They don't have to utilize any other apps that they don't already use in their everyday life. When it comes to Waze, we're actually the largest third-party provider of hazard information globally, and we partner with them extensively, have a great relationship. We did not tell them to do this new emergency vehicle icon. However, we did work very closely with them to help put the idea in their mind. I'll be very careful with my language around how we help them from that side. But from our perspective, we can look at both moving alerts, so be that moving emergency vehicles, but then also the static, and also looking at lane closures, lane blockage as well. As I mentioned, we also go live into Apple Maps, being able to look at static and stationary alerts. But the key area where we find ourselves as a very unique position is we work directly with the car manufacturer themselves. So we're already live with Stellantis vehicles in the United States, soon to come into the UK. And here we provide digital alerts directly into the vehicle when no navigation system is needed. This is just a short example of what this would look like in a vehicle.
Balance back in May. We're going to get you to one of the shows.
But this message and how the message works can vary across car manufacturers. So the key thing to view here, that is how we work with Stellantis in those particular vehicles right now. So that is on the infotainment system. We are working and piloting with others where it comes up on the dash. Even levels of synaptic feedback, whether it's the seat vibration, the slight vibration of the steering wheel. So again, when we look at this as a car user, when I have this in my vehicle, our approach to safety is it shouldn't be an optional extra. Just as you have a seatbelt and airbag, the ability to have digital alerts should come as standard. We work very closely with the FHWA and US DOT of how we're looking to mandate this and bring it into legislation into various different areas in the United States, and something that we're starting to actively work and get engaged with at the UK and also the European level as well. In terms of equipping, it's essentially very easy. We look at two ways. We do have our own transponders that we can use on telematics devices. However, as you saw in those previous slides, where we can partner with people and integrate with people, we actively do so. We do not want to have any barriers when it comes to safety. So where we can work with people, whether it's people who has just spoke before me that have amazing data that we might be able to utilize and drive into alerts, or as I mentioned, to static roadside equipment that's already there. These are just a handful of people that we work with in the United States. Some of these you'll also see and recognize names into Europe as well. So those partnerships have come into Europe. And we've already started our European partnership program now with around about 8 already starting to join up. In the US as well, a lot of the blue light and amber lights and red lights services actually come with HasAlert pre-installed. So Pierce and Rosenbauer vehicles in the United States come with HasAlert Safety Cloud as standard. And then taking a step back when we look at, again, holistically here, is this is a very just crude example of everything that could be connected and going into Safety Cloud. The area that I have not talked about here is how we actually start to hit 100% of drivers. In theory, if we have a connected vehicle, a connected emergency vehicle, connected work zone, if Safety Cloud is connected to variable message signs or any form of digital infrastructure, we can start to impact and actually alert 100% of drivers on the roads with digital signage, something that we're actively looking at with local authorities and major national road authorities as well, of how we start to bring not only connected vehicles together, how we could bring in digital alerting to reach a few and growing, but how we can actually reach 100% of drivers as well. And just to mention something that we did at the start of the year, beyond that connectivity of those blue lights and emergency services, etc. At the start of this year, we unveiled and showcased the first of its kind ever cross-brand vehicle-to-vehicle communication. So we had a VW vehicle with a hazard lights on, and then it informed a Stellantis vehicle that vehicle was broken down. So this is really important when we're speaking to the car manufacturers, because ultimately, if you break down in your vehicle, if you have X brand and there's Y brand behind you, you really do not care what the other person is driving. If you've broken down, you want the world to know that you've broken down and you're stuck on the fast lane of the M6. So intertwined with this, we're starting to look at how we can work and operate with eCall providers as well within Europe and bring this into the Safety Cloud solution. And I will stop there. Thank you very much, Andy. Oh, you're on mute, Andy.
We'll pick up questions at the end. All of this, getting data out of vehicles and getting messages into vehicles, requires on some communications. And we had a talk a few months ago where somebody was talking about sort of latency of cellular and stuff like that. And the very aptly named Mr. Sim, Peter, contacted me and said, I think there's a few misconceptions. So I said we would allow him to talk about what's going on in the world of comms and put some of those myths to bed. So Peter, if you would like to tell us about what's going on in the world of comms, that would be very helpful. Peter Sim.
Thank you, Andy. So my name is Peter Sim. I work for Mobius Networks. For those of you that don't know Mobius, we are a SIM provider that sells data connectivity on a plethora of different sectors, from telehealthcare to telecoms for UTC applications, and almost anything else really. Our biggest vertical is chip and pin. We've got about 80% of the UK market, and we're Verifone's European partner for chip and pin devices. And that's really our background and where we evolved from. So I can't advance my slides. Forgive me, just bear with a second. Try this. Can you see my slides?
We can see them, Peter, but it's on the title slide.
Right, okay. You see that one?
It's still the title slide at the moment.
Twiddle it. This is disappointing. Right, I'm going to shut PowerPoint down.
Yeah. I've got a copy of your slides that we could try if you want to do it that way.
I think we may have to do that, Andy, because it's
Okay,
right,
just
stop sharing. Move right.
okay. If you do I'll share my slides, Peter, and you do
Okay.
the next slide, please, as if it was
Okay.
Can you see that all right?
Yep.
Looks good.
So Andy asked me to just talk about mobile data before I get on to my main reason I want to present to you. So 3G, it's been decommissioned, the frequency is reused as we speak. Not a day goes by since the 1st of January that I don't get a phone call from somebody saying my devices started going off. Is there a problem with the network? Are you going down? And it's nothing more than 3G is literally being switched off. Unfortunately, nobody's publicising it. The networks are keeping very quiet about it. It's just being done at piecemeal, and it's causing no end of problems to myself at Mobius and other SIM providers, because like I said, the networks are just doing it piecemeal. So my advice to you is, if you've got any devices that cannot run over 2G, you need to get off 3G as quickly as possible, because it's so unpredictable now whether you'll get 3G services today, tomorrow, or even next week. Next slide, please, Andy. So this is why I asked for a slot from Andy. Back at the TTF event in Leeds last year, on 26th of April, Graham Seaton presented these slides about how he'd gone on with his closer trial at Hinkley Point. And what Graham, in my view, led the audience to believe was that the trial didn't work as expected and didn't prove to be a success, because there was latency in the system of up to about 4 seconds. And he also said that was down to the comms. While I was in the audience, I texted Graham and said, I don't think it is the comms, Graham. I think we need to have another look at this and a revisit. Simply because the mobile networks don't store and forward data at all. They just pass the messages through as quickly as you possibly can. So I didn't recognise 4 seconds latency anywhere, but yet the presentation said that Gloucester only had about 85% success rate, and that wasn't good enough to continue with the trial moving forward. So it's trying to address that point, really. So what does affect speeds with mobile networks? Next slide, please, Andy. There's many factors that can affect speed, from atmospherics that nobody has any control over, to the local mast, what loading is on the local mast, and indeed what hardware sits at that local mast. Is it a 2G cell that's being upgraded to pretend it's a 3 or a 4G cell? Is it a 4G cell in its entirety, or is it even a 5G cell? Nobody knows, unless you're within the industry and you can inquire with the networks, or you've got mapping data as Mobius has. The main reason for latency is the backhaul routing. Generally, the backhaul routing can go on the internet and it goes anywhere in the world. And generally what you find is the most cost-effective SIM or SIM provider, i.e. the cheapest, uses the cheapest route for routing. So we've had a couple of customers that had left Mobius because mobile works and everything is super, and somebody in the accounts department have said, we found this cheaper solution, we know mobile works, we'll go with this new provider, and within weeks they've come back, and it's because the data could be shipped via Mumbai and then Canada and then back to the UK, because the internet is the cheapest route to route the data, and that adds milliseconds or tens of milliseconds onto the transmission length. And obviously the most efficient, i.e. the fewest number of hops and staying within the UK, generally is the most expensive. And the third, sorry, I can't count today. I'm completely thrown with me. My slide's not working. And the final one is using a private network. Again, the Gloucester trial was using SIMs that operated over the internet. So if we can use the next slide, Andy. This slide's trying to show what impact a private network has. So a colleague of mine did a week-long trial of pings. On the far left, where it says Vodafone int, that was Vodafone's internet APN. And typically we were getting pings at about 250 milliseconds on 4G, which is reasonably lengthy. In comparison, if you look at the next column, which is Vodafone running through Mobius's private network, that's dropped to 58 milliseconds round trip for a ping. Contrast that with EE, which was 46, 3, which was 88, KPN, which is roaming SIM, that came in at 76, interestingly quicker than 3, and Telenor that came in at 146 milliseconds, all of which were quicker than using Vodafone's own internet APN. So if you want to get speeds on your mobile network, you really do need to look at using a private network. Yeah, I think that's all I want to say about that slide, Andy. This is going to be a quick presentation. So just as a recap, I mean, 4G is more than capable for most of ITS applications. You know, sub 100 milliseconds is more than quick enough for everything. I would say that it's capable of carrying 95% of future applications still on 4G, not on 5G. But just touching on 5G, if you have a connected autonomous vehicle, you really do need to use ultra reliable, low latency communications for V2X, safety critical information, because you're getting around 8 to 10 milliseconds round trip. But for that, you need full blown 5G, which the UK won't see for maybe till 2025. That was quick. Thank you, Andy.
That's fine. Thanks very much, Peter. I don't know if Graham or anyone from Vodafone wants to say anything just to round that one off while we've got Peter available and he's mentioned you, or do you want to discuss that at the end? Please let me know if you wanted to talk about that. Okay. So we'll pick up those sort of detailed questions at the end, but if anyone wanted to raise any more questions about 2G and 3G, we'll do that at the end as well. When we did our ITS UK seminar a week or two ago, I sort of did a review of where we've come on in the year since I last did my slide package about who pays for this. And I think DFT and have done quite well in terms of launching things such as digital TROs and MPP and so on and so forth. But there's one area I said, which was in terms of purchasing mass vehicle data, floating vehicle data, and make it available to local authorities. And then I was reminded that DFT does already do that. So we've asked Dominic from INRIX just to give you a minute or two on what's already available to local authorities, basically so you don't buy the same thing twice. So Dominic, thank you very much.
No, thank you, Andy. Let me see here about slides also. Hopefully you can see my slides.
Yeah.
Fantastic, thank you. So hello everyone, my name's Dominic Paolo. I'm Senior Director at INRIX and I'm responsible for all of our public sector business in the EMEA region. And as Andy has highlighted, he asked me to provide a very, very quick update in terms of INRIX's provision of data. Obviously, like industry colleagues before, we collect data from connected cars, high fidelity GPS data updated in near real time from disparate sources. We don't actually generate any data ourselves. We either buy or barter data from various different suppliers in the marketplace. And we bring that all together and we provide that back out in real time to a number of different customers, those in the public sector, those in the private sector, and also those in the enterprise sector. And for those in the public sector, where we provide data to government, and please note that we don't sell data, we license data because we license data from our suppliers. It can be directly sub-licensed to any other government body without additional fee. So in essence, once we've sold once to one government entity, it can be provided to any other government entity, or for that matter, any other third party working on behalf of a government entity. So a consultant doing a particular job on a particular area that might have a need for data. If that data has already been taken by a part of government, it can be provided to that entity working on their behalf. The data is typically licensed in perpetuity, so it's there for forever. The only one thing I would mention is that it does require what's called a data usage agreement that needs to be signed with the original licensee. INRIX has the privilege of having a number of customers within the public sector within the United Kingdom. There's a sample here below with the website links. Obviously, the slides will be distributed afterwards, and you can go onto these links and you can see the data provision that's provided. INRIX's name won't necessarily be put on these, but this is data that is acquired by government and then can be shared further out. That was a very, very quick update on my behalf. Happy to take questions later. Thank you very much. Andy.
Thanks very much, Dominic. So just to round things off, that's when we said government should buy more data and make it available to local authorities. To some extent they do. We'd obviously like them to buy lots more from all of the people who've presented today and more in order to make sure that that was much more easily available. But I just wanted to make sure we tied that one off. So we have a good bit amount of time for questions before I give you an update on from Darren. So there's some of the questions that popped out was, let's do the ones about comms first. Can you provide an example of a ULLC network, Peter? You're on mute.
There we go. I'm not very good afternoon, am I? In the UK, I can't give an example of a ULCC network at the moment that isn't private. So you've got them. Felixstowe Docks is a ULCC site where they're controlling some of the autonomous type movements as a pilot, but on the road network, I can't give an example of ULCC.
Perhaps some of our colleagues from Vodafone might be able to talk about that. So Graham has put a comment that he's come to the view that latency was due to the interface with the signals, and variability in the latency was the key issue. So I think you're all rapidly coming to the same kind of.
It took a discussion in late May with WSP as well, and Jason Burrows though. But yes.
Right, it was just making sure we get the record straight, but also the perception that data is slow if you buy it in a particular way. So thanks very much for that, Peter. Other questions that we've had were about 2G and 3G from OEMs and vehicles. So I know that there are various vehicles that use 3G for their connected services, which are dropping off the network, particularly slightly older ones. 2G is still going to be around for a bit longer, which is useful because we use it for eCall amongst many other things. But many of the things you were talking about, Peter, are things I believe like parking meters and comms to remote devices, smart meters, burglar alarms, you name it, as well as cars.
Yeah, anything. I mean, traffic light control, enforcement cameras, use my SIMs. NERTS, the roadside telecom service for national highways, I've started deploying my SIMs. So anything that needs to be connected, really.
Right. So I'm glad that Peter from Millbrook, UTAC Millbrook, put his hand up, because I knew he had a private ULLC network. So there is one in the UK. And I think Gary's from the FT has said, is it required for certain V2X use cases? You said, Peter, I think that there's majority of them don't need that very fast speed, and I tend to agree with you. And Vodafone have got one at Millbrook as well. So I think we kind of wrap that one up and look forward to testing and showing that's the case. I know that Peter in particular at UTAC has been playing with lots of things showing low latency, driving around his network, very fast speeds, both data and vehicle wise. So I think the thing about 2G and 3G is it's not just about connected vehicles, it's about a whole load of other things. We have been with one of my other hats off speaking to Ofcom about that, because it is coming, and as Peter said, it's the sort of thing where you suddenly find it's not longer there this afternoon and was there this morning. The 4G and 5G, particularly in terms of systems like eCall, will be protected by European directive that was signed the other week. So the question, will the introduction of 5G change the URLLC landscape, or do we think it needs to be far faster than 5G? Peter, I don't know if you want to cover that one.
I don't think it needs to be faster than 5G. The systems that I've seen demonstrated, as long as it's around the 10 millisecond latency, it's more than fast enough.
Thank you. Good. Okay, all these slides will be made available, so if you haven't been able to read them, we'll put them out there. So other points that have come up was Richard pointed out that Ordnance Survey also have a speed and speed limit data set. So again, it's been useful today in terms of just revealing where all that data is that people may not know of. I suppose that this is leading me with my TTF hat on to produce a page on the website so that people will be able to find this, discover it, and not go around. So again, if there's anybody else who knows of large national data sets beyond things like Bus Open Data Service, Street Manager, etc., I think we're starting to get the picture now that there's quite a lot of data that is becoming available. The challenge is that people don't necessarily know it's there. Similarly, as we've heard from our ASIN and aerodynamics, data directly from the vehicle being processed, and from Gareth, data into the vehicle. A couple of years ago, all this was PowerPoints, and it might be nice to see this, and now it's real messages in real vehicles. So I look forward to seeing more of that. I'll come on to when we might be able to show some of this off technology to you later on at the end of my session. I'm just going through the questions. Sources of connected vehicles, depending on how they're connected back to the OEMs, they should be able to confirm that. I know there's been lots of discussing about trying to retrofit some of the older cars from 3G to 4G. It's a bit of a challenge to do. And again, the point there being that we can't just rely on new vehicles coming off the factory. Average age of a vehicle, I always have to say this in every presentation, courtesy of the SMMT, but it's nearly 9 years now, 9 years old now, particularly of cars, older cars on the network. I think we've covered off the questions for NERA in terms of number of vehicles on the network. How many vehicles do you have? So again, thank you very much for joining us there, Henrik. That's a very useful one. The reason I asked Henrik to display was I was up in Scotland and he was able to show in real time how bad or how good the traction on the roads in Scotland were. And I said to him, yeah, but it's snowing in England as well. And he went like this on his screen, and there was a picture of England in real time with where the roads were losing traction from his customers' vehicles. I'm just looking through. Okay, so John has posted a video about latency on 5G and edge computing. We'll make sure that's available. Thank you very much for that. Peter's got to disappear. Peter's retiring from UTAC at the end of March. He's been incredibly helpful to TTF in letting us display things, blow things up, drive things around the network. So in case I forget to say, Peter, thank you very much and enjoy your retirement. I'm sure you will not go away quietly. Again, more messages about 5G being fast enough. So I don't know if anyone's got any more questions. If not, we could try and give you some of your afternoon back. So I will now show some messages from our sponsor, Darren. So you've seen this was the introduction basically that said, since we last met, we keep getting new sources. We've had the National Parking Platform and the Digital Traffic Regulation orders launched. There was a request from Peter about clarity, which I think we've done. And we did a webinar a few weeks ago on who pays and the ITMF funds, which will come up with you on the next slide. And the so what of all this is now starting to emerge, I feel, in terms of road safety. I'm very pleased that Richard could join us because the road safety world and the traffic world don't often meet as well as we should do. Plug for a conference I was speaking to on March the 6th called Joining the Dots, where that will attempt to be done. That's been run by Agilicis. But also the asset management side, as we heard, potholes are a large value for the road operators, but also increasingly winter maintenance and so on. At the same time as we're starting to get more of a focus on the niche AVs than perhaps we're going to get automated vehicles of every type are going to be here. So in terms of ITMF, some of you will like a background to that. It's available on the TTF website. So in essence, Wesley did a good plug for it. It's about making sure that we manage roads from traffic management point of view using newer technology, but let's not throw away stuff that works. And this is funding to go to local authorities, which will be launched in April. And the guidance for that is currently being reviewed by DFT. So I haven't seen it because I'm helping people with their bids, but Darren assures me that he's beavering away reading it at the moment. And that will be launched soon. It will tell you how to bid, so on and so forth. The messages from Darren, that if he were able to speak, would be don't try and use a piece of kit and then find a problem to solve. Please come to us and say our policy problem is safety, congestion, emissions, accessibility, joining up, levelling up, except freight and logistics, accessibility, all that kind of stuff. Don't come and say we want to use an Okey-Dokey 2000. He's very keen that we use artificial intelligence, as Richard said, AI is everywhere, big data, but still use the more established but still emerging and new technology stuff. Start to form consortia, so there is a whole idea of that these should be groups of people coming together from SMEs and academia through to the local authority. You must have a local authority on board. Lots of people have said, oh, what about the procurement? How are we going to do that? That has to be through your local authority, but we have got the examples of the letters that Darren will write to the local authority that says, here's your grant letter, so you can open the doors so that it's not a surprise for the procurement people. And some people have said, can we have a dating service? Can we have a kind of speed dating for people who've got services or equipment, local authorities? We don't want as TTF to kind of get involved in the running the equivalent of a dating service, but what we will do is put a very simple thing on the website. So you'll be able to say, I'm Acme, I have this service, please contact me at this, or equally, I'm Trumpton County Council and I want to solve this problem, please contact me on this number. A couple of plugs. The TTF Electric Vehicle Working Group is next week in Bolton. Special prize for anyone who knows what town Bolton is twinned with. There we go. The next BPA Smarter Parking meeting is on the 22nd of March. Richard's put a plug for Joining the Dots, which is on March the 6th. So, again, thank you very much for Road Safety World joining the traffic world. I think Richards and I have had long discussions about this. I think we live in too many silos where people are collecting data about stuff that really we don't share. We don't share our new technologies and we don't bring things together that we should do. So I'm very, very pleased to talk to him there. BPA Live is on the 29th of Brighton. Bolton is indeed twinned with Le Mans. I wonder how I might know that. And a final plug for you is that our Connected Vehicles Working Group will be meeting in person the day before the full 2-day working group for TTF in Leicester. So we'll meet on the 23rd of April. TTF big event is 24 and 25. We'll be meeting in the afternoon, a bit like we did in Birmingham back in the autumn. So I'd like from the more active of you in the group some ideas of what we should best do there. We've covered over the new data and new services to vehicles. We've talked about who pays, and we've talked about some of the things that local authorities are doing. So if you've got some ideas of what you want to cover there. I think I've covered off all the things in the chat. So if there's no further questions, I'll just thank Claire, particular Elcraig, for putting this together. I think despite the best that Microsoft could throw at us, we've had a good seminar, and thank you for all your sensible questions. These slides will be made available as soon as we can through the TTF website. If you want to go back to any of the speakers and ask them more, their contacts will be available in more detail. So again, thank you very much indeed for coming. I don't see any more questions. I'm going to give you 15 minutes of your day back. Thank you very much, and look forward to seeing some of you in Leicester, and some of you at BPA, some of you at electric vehicles, some of you at smarter parking, and some of you at joined in the dots. So thank you very much, all. Take care.